This is section 1.3. This is the first of 2 videos for this section. If I hit the right button. Okay, we're going to look at collecting sample data, different methods of sampling a population. What we really want to be able to do is called a simple random sample. That's like the gold standard. It's not easy to do, as you will see. A lot of the stuff that we do in this class, problems and such, a lot of it's observational studies. Some of the problems are experiments, and I think you learned about experiments in other science classes, so I won't cover them in depth. You can read the section about them. But the big difference is, with an experiment, you impose a treatment on someone. You've probably seen the diagrams and such where you have a control group, then you have a treatment group. Think about medicine. These people get the meds. These people get the placebo, the sugar pill, and then you can compare the 2 groups and see if the medication was statistically significant. Observational study, you're just sitting there and you're watching something. Maybe you're watching hummingbirds around a feeder, but you're not doing any treatment on them. Jane Goodall and her studies on gorillas always come to mind. This is kind of neat. It can review parts of last section. Ice cream causes drownings. Basically, because when you have an increase in ice cream sales, when you're selling more, we see more drownings. Certainly a correlation, absolutely. But as we learned before, correlation does not imply causation. So we could do an experiment where, okay, give a bunch of kids some ice cream, give another bunch no ice, or don't give them any ice cream, and see that the rate of their drownings are about the same. Not a very ethical experiment for sure, but better than the observational study. Okay, here's a definition that's going to cause you pain in this course. I know it already. I will cover this in depth in the next video, but right here, I'm going to cut it off right here. A random sample. It's weaker, but all members of the population have the same chance of being selected. That's the definition of random. Same chance of being selected. I put 5 marbles in a hat. I pick one of them. Well, each one had a 1 in 5 chance. So random. Simple random, we have to look at our sample size, which is always little n, and that plays into it. And I'll do this in more depth in the next video. Systematic sampling. Oh, I see a bunch of people in a line. I'm just going to go up and survey every 3rd one. Not random, because these people had no chance of being selected. Convenience. I'm just going to sit here and ask people as they walk by. Definitely not random. But this is what you see. Walk out of a grocery store, there's someone with a survey questionnaire. I never answer those. Stratified. Suppose we were doing a study where we wanted to compare men versus women. Well, it's natural to put them into 2 groups or stratum And we would then randomly select within each. So we would randomly select 3 here, and then go to the other group, in this case women, and randomly sample there. Now compare this with the next one, cluster sampling. See all these city blocks, it would be tough to do stratified because you would have to do every block and then randomly select within every block. Instead, you make the blocks what we call a cluster, and then we randomly select the clusters. So here's the 3 we selected, and then you survey all members of the cluster. So instead of having to go all around the city, we just have to concentrate on those 3 blocks. Just to end this, just some different types of observational studies. Cross-sectional, if I asked your opinion today on the coronavirus, that's one point in time, I'm doing cross-sectional. If I was to interview and say, well, how have your thoughts on the virus and the pandemic changed over time? I would be going back and trying to collect data from the past up till now. I always think of prospective, I always think of longitudinal. That would be, for instance, oh, you would be a cohort of statistics students. How successful are you going to be when you transfer to a university? We would continue to study you throughout your university career. Yeah, there's a lot of sampling errors. If you ever go into statistics, you'll take a whole class just on sampling. So usually what happens is not so much this. You can do a random method, but there's something went between the sample and the population. Something went wrong there. Usually it's the non-random, you know, like systematic, convenience, things like that. That makes a study not worthwhile. And of course, there's always human error. I do it, you'll see it all the time. I'll type wrong numbers or input stuff wrong, and of course that will make my statistics wrong. So that's just an overview of this section. In the next video, I'll look at the different types of sampling in much more depth.